A college awarded 38 medals in football, 15 in basketball, and 20 in cricket. If these medals went to a total of 58 men and only 3 men got medals in all the 3 sports, how many received medals in exactly 2 of the 3 sports? So we have to plot a Venn diagram here to make sense of the different values that have been given here. So let's have a Venn diagram with 3 sets because there are 3 sports given here: football, basketball, and cricket. So let the set F be the set of people who won medals in football. Let the set B be the set of people who won medals in basketball, and let the set C be the set of people who won medals in cricket. We are given that the number of elements in the set F is 38, the number of elements in the set B is 15, and the number of elements in the set C is 20. We are also given that these medals went to a total of 58 men. Now it's possible that a particular man could have won a medal only in one of these 3 sports. It's also possible that some people could have won medals in more than one sport, in 2 sports maybe, or in 3 sports, in all the 3 sports. We are given that 3 men got medals in all the 3 sports. So the size of this set over here, this is the set of men who got medals in all the 3 sports, because this is the region common to all the 3 sets. So the number of elements in F intersection B intersection C is 3. Now one thing that is implicit in this problem is that a particular man cannot win more than one medal in a single sport. So when it's mentioned that there were 20 medals given in cricket, for example, it's understood that these 20 medals were given to 20 different people. So the same man is not getting multiple medals in a single sport. The same man could get multiple medals across different sports. So this is something not stated in the problem, but it's assumed. So a given man could either win no medals, or he could win a medal in one sport, or he could win 2 medals in 2 sports, or 3 medals in all the 3 sports. Now the total number of men to win at least one medal is 58. So the number of elements in the set F union C union B, this is the set of all men who won a medal in some sport, at least one of the 3 sports. So this number is 58. So 58 men are receiving medals. Among them, 38 are receiving medals in football, 15 in basketball, 20 in cricket, and 3 of the men got medals in all the 3 sports. And we are asked how many received medals in exactly 2 of the 3 sports. Now, in which region of the Venn diagram would those men lie? Which region of the Venn diagram corresponds to the men who are winning exactly 2 medals? Well, this is one of the regions. This is the region consisting of those men who won medals in football and basketball. This is the region consisting of those men who won medals in football and cricket. This is the region consisting of men who won medals in cricket and basketball. So we have to figure out what is the number of elements in regions 1, 2 and 3 together. So let's use the formula that we had derived for the number of elements in A union B union C. That was the number of elements in A plus the number of elements in B plus the number of elements in the third set minus the number of elements in the three sets 2 at a time, plus the number of elements in their intersection. Now what values are we given? We are given this value. This is 38. This value is given to be 20. This value is given to be 15. And this value is given to be 3. So if we use this equation, we can get the values of these three numbers put together. So we can get the number of elements in F intersection C plus the number of elements in C intersection B plus the number of elements in B intersection F to be 38 plus 20 plus 15 plus 3 minus 58, taking this 58 on the right hand side and bringing these three values on the left hand side. Now 38 plus 20 is 58, so this 58 will cancel out with this 58 and we'll be just left with 15 and 3, so we'll be left with the number 18. So 18 is the sum of these three values, the sum of the total number of elements in this set plus this set plus this set. So that is the total number of elements in this set plus this set plus this set. Now if we add up these three values, notice that we would be adding up the values over here, or the number of elements over here, 3 times. Once when we are counting the number of elements in this set, once when we are counting the number of elements in this set, and once we are counting the number of elements in this set. But the elements in these three regions would be counted exactly once. So what we need to do is, from the sum of the number of elements in these three sets, we need to subtract out the number of elements in this region 3 times, because we don't want to count these at all. We just want to count the number of elements in this region plus this region plus this region. And in adding up these three values, we ended up counting the number of elements in this region 3 times. So from 18, let's subtract out 3 times the number of elements that are common to B, F and C, or which lie in this region, and that's 3. So this value is given to be 3. So 18 minus 3 times 3, which is 18 minus 9, would be 9. So 9 would be the sum of the number of elements in region 1 plus region 2 plus region 3. We can do this more formally also. So let n1 be the number of elements in region 1, let n2 be the number of elements in region 2, let n3 be the number of elements in region 3, and let the number of elements in this region be, actually we don't need to use a variable for it because we already know that there are 3 elements in this set. Now the number of elements in F intersection C would be n2 plus 3. n2 plus 3. So this can be written as n2 plus 3. The number of elements in C intersection B would be n3 plus 3. This would be n3 plus 3. The number of elements in B intersection F would be n1 plus 3. So adding these three values, we already know that the sum of these three values should be 18. But we have to figure out what n1 plus n2 plus n3 is. n1 plus n2 plus n3 plus 3 plus 3 plus 3 should be 18. So n1 plus n2 plus n3 should be 18 minus 3 minus 3 minus 3. That's just 18 minus 3 times 3, which is 9.